Hello, everyone. Today, we will explore the case model setup of the laser marking unit. Laser marking technology plays a crucial role in modern manufacturing. It not only improves production efficiency, but also reduces production costs. We will cover the content from several topics. Through this lesson, we will master the setup methods for basic physics, joints, constraints, sensors, and actuators, laying a foundation for future work in related fields. Now, let's look at the specific operational steps. We will begin the demonstration of the specific steps. First, open the laser marking unit case model. Click on the application module, then More, to enter the Mechatronics Concept Designer module. Now we will start setting up basic physics, joints, constraints, sensors, and actuators. Click on Rigid Body under the Mechanical menu. Set the unengraved and engraved materials as rigid body. Since one tray contains several materials, we can select the entire sub-assembly in the Assembly Navigator. Click on it. Then click the dialog box in the upper left corner. Choose Rigid Body, More, to see all dialog options. And click Apply. Next, set the engraved material as rigid body as well. Similarly, set the movable parts as rigid bodies, such as the blocking cylinders 1 and 2 and the ejecting cylinder. Now, we will set these one by one. Set models that can move simultaneously as the same rigid body. And click Apply. Using the same method, set the blocking cylinder 2 as rigid body. And click Apply. The ejecting cylinder is blocked. We can hide the engraved material in the Navigator, then set it as rigid body. Select it. Click OK. The rigid body setup is complete. Next, set the contacting parts as collision bodies. Display the engraved material. Click Collision Body in the Mechanical menu. First, set the conveyor 1 as a collision body. Then set the conveyor 2 as a collision body as well. Set the trays in contact with the conveyors as collision bodies. Hover the mouse over the tray, right-click, select it from the list, choose the tray entity. and click Apply. There's no need to change the name since we've already set it as a rigid body, and it will automatically classify under the previously set rigid bodies. Using the same method, set the second tray as collision body and click Apply. The blocking cylinder 1 also contacts the tray, so set it as a collision body. The blocking cylinder 2 also needs to be set as collision body. Additionally, the top surface of the ejecting cylinder needs to be set as collision body. The rigid body and collision body settings are now complete. To continuously produce materials, set the unengraved material as an object source. In the mechanical menu, click on the downward triangle on the rigid body, then Object Source, select the unengraved material, and click OK. Next, set the blocking cylinders and the ejecting cylinder as sliding joints. Click on Basic Joint under the mechanical menu, and select Sliding Joint. Since we haven't set the rigid body properties for the blocking cylinders, only select the attachment here, not the base. Specify the downward vector orientation and click Apply. Using the same method, set the blocking cylinder 2 and the ejecting cylinder as sliding joints. Select the attachment, the blocking cylinder 2, specify the downward vector orientation, and click Apply. Similarly, set the ejecting cylinder. It should be noted that its orientation is upwards, and click OK. After setting the sliding joints, move on to Position Control settings. Click Position Control under the electrical menu. Select the 3 sliding joints we set up, and set them as Position Control. It should be noted that we won't set the destination value now, but input a speed value. The destination value will be set in the logic control later. Click Apply. Using the same method, complete the position control setup for the blocking cylinder 2 and the ejecting cylinder. You can also perform the operation in the navigator. Select the sliding joint and click OK. Next, click on Transport Surface under the electrical menu, and set the 2 conveyors as transport surfaces. Select the conveyor, and specify the leftward vector orientation. Note, these 2 conveyors should move simultaneously with consistent speed and orientation. Click Apply. Set the second conveyor with the same leftward vector orientation. We won't control velocity here, as we will set this in the logic control later. Click OK. Next, set up force sensors. Click Collision Sensor under the electrical menu, and perform settings for the force sensors one by one. Select the first sensor, and choose Line in the Collision Shape option. This sensor identifies the workstation for RFID data collection. Set up the second sensor, which triggers after reaching the engraving workstation. Similarly, set up the third sensor, which is for material collection. The last sensor differentiates between unengraved and engraved materials, identifying the object transformer. Choose cylinder. And click OK. After setting the 4 sensors, set the object transformer in the mechanical menu. Choose the 4th sensor reset, and transform the object to rigid body, which is the engraved material. We mentioned that the 2 conveyors should start or stop simultaneously with the same speed and orientation. To facilitate logic control, set both conveyors to be controlled by a single signal.